Hey guys, welcome to my YouTube channel. My name is VPNOPC, and in this video I will explain in details my application that is a RAG app for retrieval augmented generation, where you have your in these applications precisely I have a local system. That means everything is runs on my computer. I have installed the model that we use here is Llama 3.2, but I also have many other models that we can test the app with, like Phi for Microsoft, like Quen, and yes, and we can test all of them. But the goal of that app is that it uses your grounded data and documents that are stored as a vector database to be able to answer questions to the users. So that means it doesn't just use a general knowledge that those large language models have, but it retrieves only the data that is stored in the document that you have locally to be able to answer the questions to the users. And when it doesn't find the right answer, it it has a fallback message that say, hey, I couldn't find that. Maybe connect with your local administrator. And the use case that we have here is it's a ministry app for a church-based context. Let me show you precisely in Explorer. Okay, even here I've built in using those libraries LangChain. LangChain is a Python framework that is used to connect large language models with prompts, with tools, with memory, and with retrieval systems. So it's an equivalent of Copilot Studio for those that use low code for Copilot Studio, and ChromaDB is used as a vector database. It stores the item as index and as numbers. So when you give your file, the ingestion of the file is that it takes your file and it split the file into small chunks, and those chunks we have an embedding model that is attached with ChromaDB per default. The name of that model, I believe I have it. Hold on, let me let me scroll down. That model, I should have it here. It's a version 6, yes, it's R mini LML6v2. This is a challenge for me to remember this. R mini LML6v2. Yes, so it stores the data as a collection. So in the code, the database in ChromaDB is a collection. It's called a collection, and we use that to find some relevant text chunk. Yes. So now if I go to VS Code, you will see this is my project. It's a ministry assistant. You see in the API settings, I use here Fast API to route all the queries that I have in terms of some specific routing, so that I can call them with some external system like Copilot Studio. I built some custom connectors to use it. So I can also use some external notification or integration with Teams and stuff like that. Yes. So I have my API host, that's the address. I have the port. I have the allowed origin here. I have the admin API key. It also have some role-based access control in the app. We have the Olama host. We have the Olama model that we use here, that is Llama 3.2, where we can change it. We have the ChromaDB part that is a data ChromaDB. It should be this folder, is right here. And then we have some predefined JSON-L data that shows a little bit the model, how the data is structured and how we want it. Like when a person put a request, a prayer request, for example, we have the request, we have the summary that the model does. For the summary, I think we have that not in the settings, but in the prompts. We have some prompt here that say prayer summary prompt. Summarize the following prayer request in 1-2 short sentences suitable for a pastoral prayer list. Do not invent details that are not present prayer request text. This is what is called generative AI because it will generate a content depending on what you ask. Yes. And then we have the system prompt here that is a prompt engineering. For those that do not know, that is a prompt engineering because you give it some tasks to do, like you say you are a helpful assistant for this ministry, answer questions only using the provided documents. So you give them some tasks to do in some context. So use only the provided church document. Always split into numbered source. So when it answers, it will give some source, some citations, and it says respond in this language. In that system, the user will choose the language and it will be passed here, and also the context of the question as well, all of this. And to run the fast API, we use this command, use this uvcon. So you run this command and it will run things for you. So now it's waiting for request already. Yes. But also if you want to use the graphical interface, we have a library that is called Streamlit that we use, and you also have to run that. So to run Streamlit, you have to run this one, this app.py. It uses Streamlit to render everything and call the right route for you. We will not do that right now, but what I wanted to show you the settings of the app. For the settings of the app, we have the name of the app. I showed you already the embedding model name, all mini LM L6V2. You can change that. We have our ChromaDB path, and the ChromaDB is persistent. That means the way we created it is that it creates just one time, and the rest of the time it doesn't create all the time. If you don't do it, it will recreate the same database all the time, and we don't want that. We have the LLM model, we have the host that is Olama, and we have the chunk size for the items, the chunk overlap. We have the retrieval token, the max distance is 1.4. And then we have the content type. Each time that we want to ingest items or document inside our applications, we have content types, sermons, prayer guide, frequently asked questions, Bible reference announcement. So just to give you more context on that, let's go to the ingestion folder. So it is here. This is the pipeline. Ingestion folder is the process from getting the documents and following the acceptable extension, because we accept only docs, Excel files, PowerPoint, HTML, Markdown, TXT files, JSON files, or other type of files. We don't accept them. So the process of ingestion is that when you upload the document, it extracts the text, it split the text in terms of chunks, and then it tags it with a content type that I showed you here. The content type that we have: prayer guides, sermons, frequently asked questions, Bible references, announcement. Once it does that, it saves the original files. It saves the original files here in the folder called documents. We have them each depending on the content type. You have the files here. You can see some document here. That's how we do it. But we also have the ChromaDB where it stores the chunks in terms of vector store. And those chunks are are labeled with the chunk ID and the content type as well. And it helps in the way that when you upload a second time the same file, we want to do what is called deduplication. And that deduplication, it will help to offset. Offset is a mechanism that instead of inserting the same file twice so that it will double those chunks, it will just update the ones that you had before. So update instead of inserting brand new. So the ingestion is in the idempotent. Each chunk ID is derived deterministically from the content type, the source file name, the content hash. All the documents that we upload, they are hashed using um the hash system. So as you can see here, we have SHA-256. So that's what we use here. So when we ingest, each time the data that we send are hash using SHA-256, and then we check if any document in the store, in the Chroma store, is already there using the file name and using the content type. Remember, for our hash here, we use the content type that is either prayer guides, sermons, frequently asked questions, and stuff like that. We have the content type, you have the file name, the title, and then the content hash, the chunk ID. So if we see that it exists already, if the existing hash is equal to the content hash, that means we just return, we don't do anything. If not, we start then to extract the section and then to do the hash of the new content and put it in the Chroma store. So that's how it works. Let me share this with you. So the deduplication that we do in our app is that we have two type of deduplication. Like I mentioned to you, we have the pipeline where most of the time, if we upload a file twice at the start when I was working with this app that I have built, if I uploaded a file twice, it will chunk it twice. So it would double the amount of chunks that we had. So it will store that file twice in the database, so we'll have duplicate. And that's not really what we want to do. So how I solved it, we had to do what I just explained to you. We hash the uploaded file bytes, and then we check if the exact file hash exists already. If yes, we just skip it without doing anything. Or if it doesn't exist, we take the content hash, the file name, the content hash, and the chunk index, and we store it in the Chroma store. Yes. Now we have another one, another deduplication. Now is the retrieval deduplication. Here it works in the store. Let me show you the store PY. I'm looking for it. Store PY, yes. So how does it work? All Chroma access goes through this module of store PY, and then relevance filtering is that Chroma's query always return the nearest neighbors, whether it's relevant to that question or not. But to avoid grounding answer in unrelated chunks, the query retrieves more candidate than needed. Yes, because it retrieves the nearest neighbor, like we mentioned. And then it drops candidate whose distance exceed a configured threshold. So we have a configured threshold, and those that exceed that configured threshold, they are skipped. And they are dropped as near duplicate chunks. and returns the most top k of what remains or nothing at all if nothing passes. And we have all of them here in the settings, these values. The max distance is 1.4, and then it drops this amount of candidates. Yes. So let's take this example here. So the threshold below were chosen by querying the bundle document, yes, with Python script eval retrieval, comparing relevant topic like anxiety, service time, foundation of faith against clearly unrelated one like car engine repair, stock market forecast on this comma collection. Default distance metric that is squared L2 over that embedding model all mini LM L6 V2 embedding. Now the observed range that has been done in that test is that in that evaluation, anxiety is around 1.14, 1.46, service time 1.02, 1.27, foundation of faith 0.63, 0.91. Now car engine repair 1.59, 1.67. You see that the distance is largest. Stock market forecast 1.46, 1.54 is unrelated. So a distance of 1.4 sits just below the unrelated queries. Lowest distance is 1.45 and above nearly all relevant hits. So it is used as a conservative general cutoff. We run the evaluation script whenever the embedding models or document set changes materially. So I have to rerun that file, that script eval retrieval py. So it's inside this folder script, this one. So this is what it does. It print observed distance for a set of relevant irrelevant test questions against currently indexed collection to support choosing retrieval max distance, scripture max distance in the settings. So that's what this is for. So let's go back to, don't think we were here anymore. We were not here. So we were at the store, yes, for the Chroma TV. So basically that's it. Let's go back to Chrome. Yes. So the Chroma TV can store near identical chunks from overlapping chunks windows or from files injected multiple times before the ingestion fix. When you query, you get the same text returned like 2-3 times in the results. How? We solve it in this deduplication. So we have a near duplicate ratio that is 0.92. And then we have this function, lowercase collapse, all white pages are removed. And then like apple and oranges. So what it does, if normalize equal order, exact match after normalization. If the near match is like it's 92% plus similar character sequences. And then in query, we build the accepted list as this, the candidate, and then we skip too similar to something already accepted. Yes, and then we have the sequence matcher and the 0.92 threshold back-to-back identical, that's exact text. 0.92 is like 8% of 0.08 difference. That's the threshold, and we have 0.5 that is half of the text is shared, and 0 is like completely different. So 0.92 is tight enough to catch overlapping chunks that share most of the same sentences, but loose enough to not accidentally suppress genuinely different content. Yes. So that's how we implement those deduplication inside this application. Yes, and I think I've gone through all the part. And in terms of chunks as well, if we come to the Bible parser, here when we take the Bible verses inside the file like a prayer, let me show you how the document looks like. For example, the prayer guide, they have Bible verses, stuff like that. Sometimes in the chunks we have noticed that the Bible verse can overlap. So what we do, we use this Bible parser with the chunk, and we make sure that each chunk are split against each other. So we use that as a delimiter, and we store them in different places inside the ChromaDB so that they don't overlap when the user asks a questions like give a topic, prayer, faith, and we want to see what is the Bible verse suggestion for that topic. So it helps to fix that part as well. And another part that I have not mentioned yet is the notifications. So we have used Microsoft Graph to be able to connect this app to the email and Outlook. We have created an app registration in Azure, and that app registration. Oh, I just noticed that I was not sharing the VS Code. Wow. So what I was saying that we have the notification, and that app registration, it has a client ID, tenant ID, secret, and we have given a policy, a conditional access policy to just a shared mailbox that will be used to send email to the appropriate team when we want to escalate issues, and we use that for notifications. And we also use webhook to send notification to Teams channel when it needs for escalation and the RAC is not able to give the right answer to the user. Thank you guys. See you in the next video. Ciao.